you. All right, so our last sequence that we need to look at is called a recursive sequence, okay? What do you guys think that means? It's kind of out there, but recurring, right? Okay? It kind of means that each successive term, so the next term, depends on the one before it, okay? So an explicit rule that we've been working with, let me find the pen thing, there we go. So the explicit rules we've been working with give a sub n as a function of the term's position in the sequence. Remember we call that n, right? Okay? So that's what we've been doing. Recursive rules, though, give the beginning I think I spelled that wrong. I think it's just one n.
No, it's actually two.
It is?
Yeah.
Oh, that looks really weird. Okay.
You want to know how I remember that, guys?
Yeah.
No. Sure. Because there's baseball in the Bible. In the Bible it says, in the big inning, which is big inning. Like,
That's pretty good. I like that.
I didn't.
I'm going to remember that.
So, in the beginning, okay, we have a term and a rule that tells how a sub n is related to the previous term. Sometimes they call that the preceding term. Okay, it's the same thing. So, that's words. Math's a language of numbers and symbols and stuff, right? So we have an arithmetic recursive rule is a sub n equals a sub n minus 1. Before we go on, though, okay? Think about this. A sub n minus 1 is just the term before n, right? Does that make sense?
Yep.
Yeah? Yeah?
we're solving for a sub n? Or what are we solving for?
Right now we're just doing the formula. Right. We're just making a rule. Okay? So a sub n equals a sub n minus 1. And then plus, if it's arithmetic, what do you guys think? D or R? D. Okay? A sub n equals a sub n minus 1 plus d. Okay? So whatever term you want is the last term plus whatever the common difference is. Okay? Yeah, Tristan?
Is it a sub n minus 1 or a sub n minus 1?
It's a sub n minus 1.
Okay.
Okay?
And Mr. Went kind of touched on that briefly. I'm going to touch on it again. Oh. A sub n, some value, some number in a sequence or a series. Okay, well, a sub n minus 1 is just the one that's before it. Does that make sense? It's just the one that's before it. That's all that means.
Okay, and then we have geometric recursive rules. So again, we have a sub n, and that is going to equal a sub n minus 1 times r. Term before it times whatever the common ratio is gets you the next term.
Okay, so explicit has been what we've been doing. We've always gone back to, okay, or always referred back to the position the term is in the sequence or the series. Well, recursive, now we're not talking about the position, but we're just concerned with the term before it.
Okay, let's look at one. So we want the first 6 terms of this sequence, okay? A sub 0 equals 1. We already know the first one, right? We can just fill that in. Okay. With recursive sequences, a lot of times you'll see this a sub 0 notation just because the first term, the a sub 1, don't you have to have 1 before it? Yeah, okay? So that's really just our first term. Okay? Now if we do a sub 1, we're going to get a sub 1 equals a sub n minus 1, 1 minus 1, plus 4. Okay, I'm going to rewrite that. A sub 1 equals a sub 0 plus 4. What do we say a sub 0 was?
1.
1, right? So I can take a sub 0 out, put a 1 in. 1 plus 4 is 5. So a sub 1 equals 5.
What's that before the age?
That's just an arrow. It kind of looks like an equal 7 though. Yeah. Yeah. That was not that much better. Okay. A sub 2. We got a sub 2 equals a sub 2 minus 1 plus 4. A sub 2 is going to give us 2 minus 1 is 1, so we have a sub 1 plus 4. What did we say a sub 1 was again? We just found it, right? 5. I erased the wrong one. Good job. Okay, so we can take our a sub 1 here and plug that in for a sub 1 in our next equation. 5 plus 4 is 9. Okay, do you see how that relied on the previous term, right?
I keep putting my foot up on the chair.
You all right?
Yeah, I'm fine.
So we couldn't just plug something in if we didn't know a sub 1, right? If we plugged 2 in there and didn't know a sub 1, we would have no idea what was going on, right? Okay, so that's the idea here. Now what do you notice? We started at 1, a sub 1 was 5, a sub 2 is 9. What's happening each time? Going up by 4, exactly. So what's a sub 3 going to be? 13. How about a sub 4? 17. And a sub 5? 21. Okay? Yeah. I mean, if you see it, that's one thing, but like if you don't see it right away, because it won't always be that easy. Yeah. Yeah. Okay. So we did the arithmetic one. Let's look at the geometric one. Okay. F of 1 equals 1. F of 2. I'm going to plug that in. I have F of 2 equals 3. Whoops. Times F of 2 minus 1. Okay. This is really like saying 3 times F of 2 minus 1 is 1. So 3 times F of 1. What did we say F of 1 was? 1. So I can take F of 1 out. Put a 1 in. 3 times 1 is 3. Okay. F of 3, same idea. Whoops. F of 3 equals 3 times F of 3 minus 1. That's like, whoops. That's like saying 3 times F of 2. What did we say F of 2 was? 3. 3 times 3 is? So what's happening each time here? Multiplying by 3, right? So 3 times 1 is 3. 3 times 3 is 9. What's 9 times 3? 27. How about the next one? 81. And 243. Exactly. Okay? Any questions on that? Awesome.
Okay, so that's a way for us to take a recursive rule and define the first 5 or 6 or however many terms we want in that sequence or series. Okay, bottom of this page, it says now we're going to write a rule. Okay, well we're going to use those equations that we had up at the top. First thing is, is this going to be arithmetic or geometric?
Arithmetic.
If I look here, I'm going up by how much every time, Tristan?
10.
I'm going up by 10, right? Now, what we need to do is we need to identify what a sub 1 is. So in a recursive
rule, we need to identify what a sub 1, or sometimes it'll be a sub 0. We need to identify what that one is. And actually sometimes it will list more than one, and we'll talk about that here in a minute. But a sub 1 is 3. That just gives us our starting point, because in a recursive rule, we need to know the one before it to know the rest of the rule. So we have to identify what that is. Okay, now a sub n, what do we say our rule is? Yeah, it's plus 1, so it's going to be a sub n minus 1 plus 10. A sub n, whatever term we want in this series or sequence, it's going to be the one before it plus 10. And that's it. Don't forget to identify what a sub 1 was, or is. Questions there? Okay, this next one. Arithmetic or geometric? Now, if I just glance here, I'm going up like what? What is this? 24? If I think about adding, I'm going up by 24, then I'm going up by 60. I automatically know it's geometric at that point in time. Problem is, what's our ratio?
2.5.
2.5. How'd you know that, Sam?
Because like I took 40 divided by 60 and then 100 divided.
Oh, okay. So we multiply to go this way. So a great way to figure that out would be to divide by going the other way. Okay. So our ratio here, our rate, is 2.5. Call that 5 over 2. Either way. Surprise me. Okay, so we need to identify a sub 1. A sub 1 is going to be 16. So a sub n is going to equal, what's our formula again? If I go back up at the top, a sub n minus 1 times whatever our ratio is. So a times n minus 1 times 2.5 times 5 over 2, whatever you want to call that. Guys, I think there's a 2 that got 3 hole punched out of here. Is that right? So maybe just write a 2 there. Arithmetic or geometric? Geometric. Geometric, right? What's our ratio? 7, I believe. We can check some of these higher ones, but I believe those are both 7. I don't know those off the top of my head, but I believe it is 7. So we need to again identify a sub 1. A sub 1 is 2. So a sub n is going to equal a sub n minus 1 times 7. All right, and this last one, I think that's arithmetic, isn't it? Going down 6, down 6, down 6 every time. So a sub 1 is 19. So a sub n is going to be a sub n minus 1 minus 6. Questions there? Okay, top of the second page, please.
All right, guys, take a little bit. Look at that first one and try to figure out, is that arithmetic or geometric? What do you guys think? Geometric? Okay.
Uh-oh.
So timesing by 1. If we times 1 by 1, do we get 2? No, so it can't be geometric. What? It is, yeah. It's recursive, right? It has to do with the one before it. Okay. Does it have to do with the one before it? See if you can find a pattern in this, okay? Talk with your partner. See what you come up with. Exactly. Yep.
No way. You genius. I want you to say it to everyone so they call me out.
Already got that one too? Yeah. I'm hearing some good stuff, okay? What do you guys think?
Adding each previous one to equal the next one.
Yeah, I think you said it kind of weird, but I think you're on the right track, okay? Aren't we just taking, like, let's look at 2 here. Isn't 1 plus 1 2?
It is.
Okay, how about 3? Is 1 plus 2 3? Possibly. Weird. Okay, 2 plus 3, what's that?
5.
Huh. Okay. 3, exactly, it's 7. 3 plus 5 is 8, exactly, okay? So here's what we're doing on this one. We're saying, okay, we have a sub n, right? We need a recursive rule for this. A sub n equals a sub n minus 2, 2 terms before it, plus a sub n minus 1, then 1 term before it. How many terms do we have to list out as our beginning terms on this one? 2, right? Because we can't just start at 1, because then what's a of negative 1, right? That doesn't work. So we need to list out our first 2 terms. So a sub 1 equals 1. A sub 2 also equals 1. Okay? What's the next term in that? So I heard geometric, and you're saying 1 times 2 is 2, 2 times 2 is 4, right? So isn't it kind of just basically the same thing, except instead of a plus sign, it's a multiplication sign? Yeah, exactly. Okay, our first term is 1. Our second term is 2. And our rule is a sub n equals a sub n minus 2 times a sub n minus 1. 2 terms back times the 1 term back equals the term we're on. Okay. Sweet.
Okay, let's go flip over to the front page again. I just want to talk about something for a quick second. Guys, if we're timing, I was looking in the book, and if we're multiplying here, normally if we have a number times an unknown, where does the number go? Usually goes in front, doesn't it? So I think that might be a better way of writing that. I don't know if the computer will be picky on that. Same thing here. I think this should be a sub n is going to be 2.5 times a to sub n minus 1. So just put that number in front. It's a better way of writing that. Okay, last problem here. I think this stuff's kind of cool. It says a lake initially contains 5,200 fish. Okay, each year the population declines 30% due to fishing and other causes. Let's be real, things might die, other fish might eat other fish, things if that happens, believe it or not. So the lake is restocked every year with 400 new fish. We start with 5,200, 30% don't make it, okay, because of fishing and other causes, but then they restock every year 400 new fish. Write a recursive rule for the number a sub n of fish at the start of the nth year. Okay, it says a recursive year, or excuse me, a recursive rule. So if it's recursive, I better identify what a sub 1 is. What is it? Yeah, that's the amount of fish in the first year. 5,200. Now, a sub n. How are we going to write this? Because remember that pendulum swing that we had?
Yeah.
Last class? It kept 80%, or it traveled 80% as far as it did the time before it. We didn't put 20% in the equation, the amount that it lost. We put the amount that it's keeping. So it's losing 30% of its fish, but how much is it keeping? 0.7. Does that make sense? If I times the fish times 0.3, that won't give me the amount of fish that are left in the lake. That'll give me the amount of fish that are dying or getting getting caught. Okay? Does that make sense? So we don't want 30%. We want 70% or 0.7 because that's how much we're keeping every year. Okay? So the population of fish is going to be 0.7 times what? A sub n minus 1, the year before. Okay? So to find the population of any given year, take 0.7 times whatever the population was the year before it. What about this 400? We add it because we add 400 fish every year. So the population of fish in this given lake is going to be 0.7 times whatever the population was before, in the year before, plus 400. Okay? So find the number of fish at the start of the 5th year. Everyone have a graphing calculator, or I guess a calculator? Here's what I want to do. I want to take 5,200, and I want you to put enter. That is now plugged in as what we call ANS, or our answer. Okay? Now, what I want to do is I want to take 0.7 times second answer plus 400. Essentially, I'm using, since it's recursive, and when I'm using my answer of my previous one to figure out the next one, I've plugged this essentially, it's an equation. So I'm taking 0.7 or whatever I had last time plus 400 and hit enter. So that's how many fish there are going to be after
1 year or 5 years? 5 years? It's 1 year.
That's just 1 year.
I know we haven't plugged this.
I think that would be the second year. Because didn't they say that this is A sub 1 right here? So that's the first year. So I think this would be the second year. Guys, if I hit enter again,
It's the 3rd year.
third year. Hit enter again. Because it's recursive and I use this answer to calculate this number, I'm using the answer that I last calculated. And I lost track. That's 4.
Yeah, one more.
Hit enter again, and I believe that's the 5th year. So the population of fish in this particular lake after the 5th year, we'll round that, sure, to the nearest fish. 2,261. 2,260, what? 2 is what? 2 fishes.
It's just
No, it's fishes.
You thought it was.
No, it's fishes.
I'm putting.
Or is it fish?
so. Do you think you could
Hold on here.
Do you think you could plug something like that into like a graph?
A graph? I'd have to look on that. How to do that recursively. I'm not sure on that. I'm sure there's a way, but I don't know that.
It could be a line.
Now, the last part here. It says describe what happens to the population of fish over time. It's decreasing, but here's what I want us to do. I want us to keep hitting enter. You're right, it's decreasing. So if it's decreasing, that means we're going to have negative fish eventually. Well, that's not possible, right? So we can't just say decreasing, because that means that over time we're going to have negative fish in the lake. Oops, so keep hitting enter.
At one point I just stopped.
You guys doing this?
It just kind of flatlines.
You guys do it. Keep doing it. Eventually, it should approach or converge on a number.
I think 133. 1,333.
And I think that is 133, excuse me, 1,333.33. We'll just call that 1,333 fish. Fishes.
Fishies.
Wait, so do we have to do like the 0.3?
We get the idea, but usually if it's something like we usually round to the nearest fish. Okay? So like Ralphie said, there's an asymptote there. We're never going to get, according to this recursive rule, we're never going to get below 1,333 fish. Tristan.
So we're not gonna like actually say decreases until we get to 1,330.
Sure, you could say decreases, or what happens, describe what happens. It approaches that many fish. There's an asymptote at that many fish, and so on.